We are going to continue with the assembly instructions. So the next component is the DEC motor mount or deck mount. So in this one, there are a few options. If you have the opportunity to buy the single piece RA wheel from the store, that is definitely great. There are some benefits to that. I'll talk about those in a little bit. And if not, you can also just download and print the parts yourself as long as you have a large enough print bed. You can definitely do it like I've done in this case. So it's a three-piece component. These two parts are in PLA. This is on PETG. Probably PETG was not a good choice on this specific component. I printed this a long time ago. So I also made some modifications. So this one, instead of the threaded inserts that we use now, I use uh, M3 nuts. And I just put a soldering iron and just put it in place. Similar to that, um, to what we're doing now with the threaded inserts. Um, so I already partially assembled this part. So in this case, I'm going to assume that you're using NEMA 17 motors for this component. So let's get started. All right. So in this case, let's see, then the step is for NEMA 17 motors. So the way that this works, this specific part here, if you flip it over, it has these holes that go through the part, and then you use the motor mount to attach the motor. And the way that this goes, I have this already pre-assembled over here, if I can show it. So the way that this works, they will go like this. Uh, and these ones have this component here, this part that allows you to slide the motor in and out. And what that will do is it will allow you to uh, set the tension of the belt. So that's definitely a good idea, especially when the weather starts to get either too hot or too cold. It can either expand or contract. So this is a great design because in that way you can adjust the tension of the belt. So I'm going to use this motor. And as well, what I do is when I mount the motor, I try to leave the plug a little bit on the outside, because if you're not paying attention, you can leave the plug like this, and you may not have enough clearance to insert the connector later on, and then you have to take everything apart once again just to plug it in. Right, so I usually leave it in an angle, and then you put the connector through these holes, so in that way you can insert it. Um, so that's what we're going to do now. And as well, you already need to have installed the pulley. If you can buy the metal pulleys for sure, that's the best way to go. Definitely there's no point on using the 3D printed ones, especially because this will be using a lot of torque. And I imagine, I haven't used the printed ones, but I imagine that after some time it might wear out. So it's important to use these ones. So I'm going to just set it in here. So first thing is for me is to insert this one at the bottom. So I have these short M screws, and the parts that you will need for these are the splitting part, which is this one, uh, and then part number 11 underscore deck underscore motor underscore mount, version 9. That number may change as well if there are any updates. The GT2 pulley, and 5 M3s by 12. So let's get started. Let me get my set of keys here. That's too small. Okay, let's align the hole. There we go. Just like we saw on the other parts, you don't want to do the final tightening. You want to leave some room as well for adjustment. Um, let's see, here's the other one. Let's see. No, this is too long. So we'll pick this one to show on the other angle here that I have. So you can see that you can still, oh, this is even too tight already. Just loosen the part a little bit and you should be able to slide it in and out um, to adjust the tension. It's a little too tight. All right, so let's leave that for now, and that's basically it. Right, this is how you connect the motor to the assembly. Can leave it here. Moving on, the next step is to attach the other components of the ring. So you will need the splitter thing part 1, part 2, and part 3. They are labeled 06A, 06B, and 06C. Like I said, I already put in here some M3 nuts to work as a threaded insert. Um, and ideally, you will put the head of the screw going this way on the top because I did it incorrectly without thinking too much about it. And this may hit the motor that will be driving this wheel. So that's something as well to consider. So let me put that here. All right. So in this case, I need to insert the M3s here. Let's flip this over. Should be good. I should probably clarify that in my case, I had to leave the screws, the head of the screws facing the other way, and that is because I made a mistake and I inserted the M3 nuts the way that they shouldn't go. But in your design, this should go on the opposite side. Let's see. So yes, the head of the screws should go on the opposite side. So just be careful of that. Don't get confused. Like I said, this is something that I made earlier and I wasn't paying too much of attention to what I was doing. All right, so let's tie this the best we can. So if you had threaded insert, that's fantastic. If you don't, you can use the M3 nuts, or you can even use just uh, make your own thread when you put the M3 screw. Okay, so let's talk about something here. So this part of the assembly is super important. It carries a lot of the weight, and as well, it can have some flexing when you get the three part. So I'm just going to apply some force here, and you see how much this bends, right? And for something that is tracking and taking minute-long exposures, that is definitely not good, right? Just it takes just a little effort for this to flex. That also probably has to do with the fact that I use PETG here, and as you guys know, PETG is more flexible in that regard than PLA. But if I had this part in PLA, it will be a little bit stronger. Um, So this is why I was mentioning before that if you can get the single piece array wheel either from the store, you can print it yourself, for sure, go for it. It definitely will add a lot of rigidity to the frame and will make things better for you. Um, so let me show some of the other options that I have here. So here I have the single piece RA. So this one is already has the motor. Um, so let's do the same test to show what the difference is. It flexes. I don't know if you can tell, but I'm applying a lot more pressure, a lot more force here trying to flex it, and it's definitely holding really, really well. Right? So as you can see, it's a big difference, right? Um, and as well in this one, I install, this is the one that I was using earlier actually. So I install a little piece of cushion. Um, Once you finish the assembly, this is where if you have the guider, the guider camera, it will be resting on the RA wheel. So that's what I use to, help so it won't damage the part. And if you don't have the guider, this is what the aluminum extrusion that is holding the camera will be resting. So that's why I put this part here. And another difference as well I wanted to show is this is the new uh, deck motor mount or DEC motor mount that it has idlers. And the reason why I have this one is because of my setup is it's pretty heavy. It's over 2 kilograms. So this definitely help to with the load to handle it better. So that's what they do here. And this design that I have here, it does not have the threaded inserts. You can definitely put threaded inserts yourself, or like I show in the other one, you can also use M3 nuts. Just put the soldering adder in there and melt them in place. Just be careful because it gets pretty soft. And if you're not careful, it might get in an angle, which will, be difficult trying to fix later once it cools down. And I still have one more. So let's show you this one. So this is the latest design that is available in the store. This is as of January of 2022. So this one, what is the difference? The difference is that it has threaded inserts. So it has threaded insert for all the holes, for everything. So you can see in here on the internal parts. And this is a modified design of myself. Um, so apparently I shouldn't talk too much about this one. Because it is not available right now. Um, Maybe in the future. But this one also has some marks here that they mark the 1 hour. If I can show it here in the camera, hopefully, let's see if I can zoom in. Maybe you can see it there. So there are two marks in here. So when you're calibrating the mount or the tracking steps, you use this as a reference. So this marks 1 hour. All right. So let's put this away. So I'm going to continue here with this component. And this one as well has the markings that I put in here. I painted in red to mark 1 hour. So when you're calibrating, you know that is moving correctly. Uh, that is moving correctly the way that it should be. All right. So moving on. Next step. The camera mount. All right, so for the camera mount, I have these. Let's put this one to the side right now for now. Um, all right, so this one I already inserted the bearing. This one is a slightly older version of the design. It's very similar. This part I think is the biggest change on the newest design that is available. And this is what you use to hold the belt that it goes around here, around this path. That's what I use to hold it. All right, so the parts that we're going to use are the U3 drive disk deck unimount, which is this one, the U1 L holder left back, U1 left holder, sorry, U1 L holder left front, the right back and the right front. You're going to need as well the bearing holder, which I already have in here. It's this one over here. And also some 8 M3 by 12 screws. All right. Oh, and actually, there was something else I wanted to show. Yes. Before I move on, I wanted to show this. This is regarding the flexing as well, the parts. So this part is printed in PETG. And this one, I want to say there has 5 walls. I'm not so sure about the info, but what I wanted to show is this. I don't know if you can see it in there, but it's flexing. And it's flexing quite a lot. I don't know if you heard that, little crack. So definitely something that you don't want. Same with this one. This one was one of the earlier ones that I printed. So this one I think has like 4 or 5 walls, maybe like 3 walls actually. Okay, so in this case, this was when I first was starting the project, and I was thinking, okay, I don't want to spend too much material. I don't know if I'm going to use this. I don't know how good this is going to be. So I'm just going to go with 3 walls, what I've always been using, and I don't know, maybe 20%, 10% infill. And I want to show you this. It flexes a lot. Not good for sure. Not even close to be good. So definitely this, avoid it. Perhaps PETG is not the best material. Maybe if you go with a super high number of walls, maybe like 8 or 10 walls and a lot of infill, it will be pretty strong. But if you can avoid it, I would say PLA. It's easier to print, much more stronger than this. So let's put those away. For now, I just wanted to show the material choices and as well what the difference that it can make to have the right amount of walls. All right, so look at this here. So for that, I'm gonna have these. I already pre-inserted the nuts, as you can see in there, to save some time. Right, and this is one of the pieces that I was using. And something important is when you're uh, tightening this to the aluminum extrusion for the camera mount, you had to be not so crazy when you're doing it. uh, you don't have to apply too much force. Why? Because you can crack it. I don't know if you can see it in there, but it's definitely crack right along the middle. Let's see, right along the middle. Apparently you can see it in here. It's definitely crack, which is definitely not good. So yeah, you don't have to apply too much force, just enough so it won't slide, and that is able to hold the extrusion properly. So for that, let's get all these 4 here. This one. So let's start by this. Okay. And as well, something I should mention is you have to be paying attention. Um, as you can see in here, one of these ones is longer than the other. So the ones that go on the this wheel, on the deck wheel, those are the shorter ones. Why? Because it has this part. See if I can show it in camera, if I can find the right angle. It has this part that it extends or protrudes a little bit. So that pushes this part a little farther away. So that's why this one, the shorter ones go on this one. And the longer one goes on this one because this one doesn't have that specific part. So that's important to keep in mind. And let me get the extrusion that apparently I don't have it in here. So I'll be right back. All right, so I'm back. All right, so let's get started. So first things first, let's put this one. The shorter ones are the silver. Yes. Let's get some M3s here. Get in there. So what I do is at least I install one of them, and then I continue with the next one. Let's see, where are my M3s? Okay, next one. Right. To use one of these right here. This doesn't take too long. All right. So we're going to repeat same steps. The next one, I'm just going to push the bearing in place. Something as well about here is tolerances. This should fit tight, and the only thing that it should be spinning, um, it is the whole part, but the internal part should be fixed. Um, so that's important as well to consider. If this thing, if you flip it over and it falls off, definitely you need to reprint it or add something there that will keep the bearing in place. Same with this one, it has to stay in position. All right. Let's see. Okay, so next one. Almost done. If by any chance these parts are a little bit loose, that you start getting to the end, it keeps just spinning, spinning, spinning. What you could do is if you have a drill, you can drill the hole a little bit deeper, so we'll get a little bit more plastic to thread in. So that's a good option there. All right, so here we go. We have these almost ready. Okay, so next step, the extrusion. So what you will need here is the 300 by 2020 extrusion, 8 M4s by 12, and 8 M4 T-nuts. Those are these ones that I already have pre-installed. And these are loose, so there's still a gap between the part and the nut, so it's easy to slide on the profile. And like we seen earlier, I just align these ones and then I just slide the extrusion there. Same with the next part here, just slide it in. There we go. All right, maybe just use your fingers to tighten this a little bit, just a little bit, so it won't um, fall off. All right, once you have it in there, then repeat the same process. Like this one there. Go. Get in there. Sometimes if they are too tight, then there's not enough gap for the part to slide in. So if this helps, you can also stand apart. I think it was too tight actually. Yep, that was the problem. So slide it in. Same thing here. Try to align it with the profile. Just a little more there. Still too tight. And still too tight. Guess lesson to self. Double check that distance that is not too tight, so have enough space to slide on the profile. Let's see about this one. It's probably too loose now. It's a little cumbersome, not gonna lie, but we're getting there. There we go, I think. Yeah, succeed. Let's see. All right. So, uh, if we keep following the instructions, it says that we need to leave a gap at the back, whatever we decide is the back. Doesn't matter here. Whatever we decide is the back is what we're going to use as a reference. So we're going to use 5 centimeters. So let's do that. Okay, let's see. We can push a little more. There's a reason why there is that gap. I'll explain it later, but it's important to leave it there. Okay. Let's see. A little too much now. If it's too much, that's okay. If it's too short, then it is a problem. Let's see. We're getting just one more adjustment. There we go. It's good enough. All right. So something as well to consider is double check that these align to the other one, because sometimes when you're um, tightening the M4 screw, this can shift to one side or the other, and then these are crooked, and that's definitely no good either, because this is supposed to be parallel to one another, right? So try to make sure that they are facing each other perfectly, and just take your time. Alright, so we're going to use, let's see, I should just use my fingers to get them finger tight so it's easier for me later on, and also that will help with alignment. It's good. Looks good. Looks good. So once again, I'm just using my fingers to tight this part. Just enough. Probably something as well to consider is, if I can show you here, the camera. I'm not sure I need to rotate. Maybe there. Is as well this. This can flex. I don't know if you can see it. Or this one. Probably this one's better. You can see it can flex. So try to make sure as well that when these are moving, when you're adjusting them, I should say, that they are aligned with one another, that one is not higher than the other or something crazy like that, right? Just to make sure that everything is as square as possible. So I'm going to start um, tightening these ones, and it definitely gets a bit cumbersome because you cannot spin freely this, so it takes a little bit of time. So with the magic of video editing, you probably are going to be spare this tedious part. As you can see, as you can see, already happened. Remember what I was mentioning about misalignment? When I started securing them, then they don't match anymore. So make sure that you always check that, because if not, that will be certainly a problem. So it's easier. Should probably secure one instead of trying to adjust both. That's not good. Let's do this one. Try to secure this one first. Show what I'm doing there. All right, so we need to fix this for sure. So let's loosen this one a little bit. Honestly, I wish that this was less awkward. All right, how does this look? Definitely looks better. You can see it in here. They do match once again, so that's important. So let's secure them. Probably this is another example of what I was trying to show earlier. I don't know if you can see it, but this angle, it's like on an angle, a weird angle. I don't know if you can see it, but this one side is higher than the other. So just double check that as well before you secure to the profile. You can probably keep one finger on one side while you secure the other. So in that way, it won't slide out once you apply a good force there. We're getting there. Getting there for sure. Same with this one, it slide out a little bit. So I'm just gonna hold it with my finger. Almost done here. It's cumbersome. Oh, big time. I guess if you have a really long hex key, Allen key, you can probably do it from here, this angle, but unfortunately I don't have one that is that long. All right, and we're good. Okay, so next step, then we join the components together. So for that, I'm going to use the piece that we used earlier, right? And this case, just like this. Um, let's see, something is off here. Ah, yes. So there's a problem. This side that I decided that was going to be the back, it is not the back and it's actually the front. That's another tip there. Things what not to do. Yeah, so that was a mistake. So I need to move this differently because if not, then it's not going to work properly for us. I can still at this point probably we'll be thinking like, oh, it doesn't matter. I'm just gonna use it like this, right? It doesn't matter if this side is longer than the other. And the reason why I was saying that it does matter is because when this part starts spinning up, it can hit the RA wheel. It can hit it, so it won't allow you to do a full spin like this when it's pointing backwards. So that's why there is a specific distance that you need to leave. Um, so we'll have to correct that so we can keep continuing with the installation. All right, let's see. Okay, we're getting there.